Okay, let's do Geometry Lesson 11.4, Areas of Irregular Figures, on page 617 of your book. What's an irregular figure? It's simply just one that we haven't classified yet. It's not a regular pentagon or any of the things that we already know about, any of the named sides. It's some kind of oddball shape, irregular shape. How do you figure its area? Well, it's just the area of the non-overlapping parts all summed together. So let's take a look at what that means. If I have this rocket ship type of shape here, and I know that the cone of the rocket ship is at the end there, and this is perfectly the same length, and we know that this to here is 19. We know that all the way to the tip to the tail is 22. We also know that each one of these little fin areas is 6, and we know that the overall height is 6. I think that's everything. Now we're to figure out the area of that guy. Well, let's figure out the overlapping parts. We can take the long cylinder and add to it the semicircle at the end, the cone at the end. But that wouldn't quite be right because we have this missing part here. So we have to figure out the size of that triangle and subtract it. So the area of the rectangle plus the area of the semicircle minus the area of the triangle. Well, the rectangle is 6 tall by 19. The semicircle has a radius of 3 because the overall height is 6. And the triangle is the hardest part to figure out. We know that one side is 6, the other side is 6 and 6. How do we know that? Well, the height is 6, so that right there is 6. We know that that top is 6. So now we have a perfect three-sided figure. That means that all our angles are 60. So I'm going to draw this a little larger. So if we know that 666, we know that that is 60 and that is 60. And if we would draw a perfect altitude on there, we now know that that's a bisector and that guy's 30. Okay, so we need to find out how long that dotted line is. Well, we have a 30, 60, 90 triangle there, this bottom half. And if you remember, if the short leg is, so this short leg is half of that, 3. If the short leg is x, then the long leg is 2, or the hypotenuse is 2x. Then the other one, the long leg, is x times the square root of 3. And our x value in this calculation is 3. So the length of that dotted line is 3 times the square root of 3. So now we can just figure out all the equations. We got length times width, 6 times 19. That's our rectangle, plus we only want half of the area of a circle. So we've got the area of a circle is pi r squared. But we only want half of it because we've got a half of a circle to deal with. So we're going to say 1/2 times pi times 3 squared. And then we're going to subtract the area of the triangle, which is 1/2 base times height. And we know that 1/2, the base is 6, all the sides are 6, and the height is 3 times square root of 3. So once we know all that, we do the calculations. 114 minus 9 times, minus 9 times the square root of 3. This is plus 9 over 2 times pi. And I punch those all into my calculator, and I get approximately 112.5 units squared. All right, try number 2. In number 2, we're showing kind of the top of a table where there's a rectangle inlaid in it, and they're trying to figure out the area of the wood around the outside. So what is the area of that wood around the outside? Well, it's rounded corners. So if you take a look at it, if you were to explode each corner, it would look like that. Well, there's 4 corners. So what do we have? We basically have a circle. So all we need to know is this side and this side multiplying times 2, and we do know that. We're given that that's 40 inches, and this is 60 inches, and we're given that the wood is 3 inches wide. So if we have we got the 2 long top and bottom rectangles plus the 2 side rectangles plus our circle, the 4 corners. And that'll give us the total area. So in this one is 2 times length times width. Well, the width is 60, or the length is 60, and the width is 3. And this guy is 2 times the length, which is 40, and the width is 3. And finally, we have the circle, which is pi r squared. And we know that the radius of each one of those guys is 3 because of the width of the whole board is 3. 3 squared. 3 squared. All right, so now we get 60 times 20. And let's just do that. 2 times 60 times 3 is 360. Plus 2 times 40, which is 80, times 3, 240. And 9 times 3.14 equals approximately 28.26. So you add those all together, plus 240 plus 60. And we get approximately, because I've used rounding and I use 3.14 for pi, 628.3 inches, and this happens to be in inches squared. Now let's take a look at the last example in the book. In this example, we have kind of an odd looking shape on a coordinate plane. Doesn't have that. Looks kind of like a house. I drew that extra line in there just to show you something, but we have the top value. T is at 110. U is at 3.7. And V is at 3.0. And R over here in this corner is -5.0. And S up above is -3.7. So how are we going to do it? The reason I drew the angle here is we can make this thing, that top triangle, plus the quadrilateral. Well, the triangle we know is 1/2 base times height. 1/2 base times height. Well, 1/2, what's the base of our triangle? From here to here is from -3 to +3, which is 6. And from this line up to T is from 7 to 10, which is, so the height is 3. So we've got our area of our triangle figured out. Now we've got to do the area of quadrilateral. If you remember, it is 1/2 height times base 1 plus base 2. Oops, write that correctly, base 2. All right, well, what's the height? Well, from 0 to 7, so we know that we have 1/2 times 7. And what's our 2 bases? Well, we've already figured this base. It was the base of the triangle, so that's 6. And now we've got from -5 to 3, +3 is 8. So when you calculate that all out, you end up getting half of 9, or half of 18, which is 9, plus 14 times 7 times a half, which gives you 49. And your final answer is 58, and it is units squared.